show that the path traced by projectile is parabola. See, let me explain. Let me take one stone. If I want to throw an air, what that path will be taken by that stone or thrown stone, that is actually parabola. We have to prove that the path what we call it as projectile. Okay, so show that the path traced by projectile is parabola. See, I am throwing the stone from this point, from the origin, say O. I am throwing this stone here. The stone will take a path like this, and then it will come down and it will come back to the ground. That's the main. When this stone is thrown, or when a body is thrown, it is going against to the acceleration due to gravity. This is going against any object. If you leave, it will come down due to gravity. It is going against to the gravity, against to this. So that's why this speed is supposed to be accelerated more than the gravity. So then only it can move like this, and then the velocity will differs, and as the velocity differs, it will come to a position where normal to the ground, and then it will take a path and it will fall on the ground. Now, we will take the component of this body. The horizontal component is u cos theta, x direction, and vertical component, say y, u sin theta, u cos theta, u sin theta. It's the prime thing that you have to understand. As any position, I can represent x and y. Any position represent x and y. When it is reaching to its ultimate height, then that position is called as h. When y reaches to its ultimate height or maximum height, that y is equal to h. Now y becomes h. Then as usual, after reaching this, once again it will come back, then again it is y. Maybe you can call it as y1, y2, y3, y4 as it falls down, and finally it will come to 0. It start from 0 going to the maximum, then it is coming back. When this particle is moving at particular place where this is maximum height is reached, so then the directional component uy is 0. It will not go further. That's why uy is 0. But this horizontal component still exists. It's moving. Horizontal component is exists. That's what ux is equal to u cos theta. I told you horizontal component is u cos theta, vertical component is u sin theta. Here u cos theta and u sin theta will exist at every point. As it reaches to its maximum height, uy is equal to 0, ux is equal to u cos theta. Here the horizontal motions will stop this. And once again, as it places its beyond this places, once again y component will exist. Y component will exist, but in opposite direction. Here it was moving against the acceleration, so that's why it shows upward direction. Now it is coming downward direction, see, downward directions. And finally when it reaches here, so uy is become u sin theta, but ux becomes 0. It will not go further here, but it will come and drop here. So minus uy is equal to u sin theta. This much concepts you are supposed to know in this projectile. So let me explain this. For horizontal uniform motion, ux is equal to x by t. This x by t is nothing but velocity. It travelled at x distance with respect to the time. It means ux means a particle which moves in the x direction to x distance, with respect to the time, x direction. See, actually the particle is moving like this. You are measuring with respect to x and y direction. So the particle is moving here to here or here to here with respect to x direction and x distance. You can take it as x distance like this, x distance with respect to the time. So t is equal to, time is equal to x divided by ux, that is the velocity component with respect to x, that is taken as 1. Ux is equal to u cos theta, you remember this, you know this. So t is equal to x by u cos theta. Just to substitute here, ux means ux, u cos theta, just substitute here. T is equal to, time is equal to x is the distance travelled divided by the velocity component in horizontal direction, that is u cos theta. So keep this as 2. Let y be the vertical distance covered by the particle in time t. If the body moving against the gravity, the motion accelerated motion. I am telling you, if the body is moving against the gravity, this is the gravity, whatever you drop it will go down. If you are making up, you are throwing actually against the gravity, it's moving. So the accelerated motion, it's called as accelerated motion. You know what is accelerated motion? In the previous equation it was derived. A is equal to, that is acceleration is equal to the final velocity minus initial velocity. Initial velocity is v naught divided by time. Actually what is acceleration? Acceleration is equal to differentiation of velocity with respect to the time, generally v by t. Okay, so v minus v naught divided by t minus, actually the final velocity if I am taking it as t naught minus t or t minus t naught, actually the final velocity if I am taking as 0, the initial velocity if I am taking as 0, sorry, initial time if I am taking as 0, the final time reached time is taking as t. So v minus v naught. Here one concept is you should understood. Nothing starts from 0. You should keep some velocity to drive any particle. That velocity is called as the initial velocity. But you can take it as the timer to drive is 0. And if the particle reaches to particular place, you can take it as time t. Okay. So if you are started driving, or if you are differentiating at particular point to particular point, then the time t1, t2 exists. If you start from the origin, you can take it as 0. Time especially, not the velocity 0. Velocity is always v naught, that is initial velocity, the time t. Okay, the final velocity, final time is a t. The initial time is 0. So take this as, so v minus v naught, that is final velocity minus initial velocity divided by tt means the time traveled, that is nothing but final time. Then you just see here, you can take it as a cross multiplication. A is equal to v minus v naught by t, and v is equal to v naught plus a into t. This equation can write this form in this form. Here the average velocity, a concept of average velocity. A body is thrown at the initial velocity, it is reaching to some final velocity. We are actually interested in average velocity. Average velocity v plus v naught by 2. Average velocity. Once you know this v, what is v? You just substitute the value of v. V is nothing but v naught plus 80 plus v naught by 2. Then you will be having 2 v naught 80 by 2. Here I am telling r minus r naught. Here one thing I am introducing. What is r minus r naught? The particle at earlier stage to the next stage, it traveled. It was r. The position of the particle was r. The next position of the particle was r naught. The first position of the particle was r naught, and the next position of the particle was r. That is the traveled distance. Generally, we will take it as straight line. Even though it is curvilinear, we will take it as straight line. The position of the particles moving, this is initial r naught to r. Any displacement you should measure in vertical line. So here to here, the position here to here, it is r naught. R naught to r. That is r minus r naught is the distance travelled, or displacement takes place. 1 minute. I will mark this as here say r naught, and here it's say r. So this distance is, I can say, mark like this, r minus r naught, r minus r naught. The particle moving, the distance, that what I use. So that is nothing but your average velocity into time. The displacement is equal to average velocity into time. What is the average velocity that we calculated here? V naught plus 80 plus V naught by 2 into t. See here, V naught t, 80 by 2 V naught into t. If you make it out like this, V naught into t plus 80 square plus V naught t. So it becomes 2V naught by 2 cancels, it remains only V naught into t, and here it is 80 by 2, that is half 80 square. If you simplify this equation, you will get this equation, V naught t plus 1 by 2 80 square. So remember this equation. That's what this equation says. The displacement of the particle, the measure, that is equal to velocity into time. That's what velocity, average velocity into time. That average velocity into time is simplified like this: initial velocity into time plus half of acceleration into time squared. Then here h is equal to r minus r naught. Here the maximum, when it reaches here, h is equal to, if you say r minus r naught, when it is coming to its maximum height position, v naught is equal to uy, that is initial velocity become the uy, the maximum component at the maximum height. So a is equal to, acceleration is equal to gravity, it's actually start falling down. So that's why it is indicated as a minus g. The particle, when it is reached here, a particle when it is reached here, h is equal to r minus r naught, v naught is equal to uy, and a is equal to minus g. Just substitute in this equation, you will replace it with this v naught to uy and of a to g. secant uyt minus half gt square. You are replaced. G is actually acceleration due to gravity. A is only gravity. G is acceleration due to gravity. Direction is downwards, so that's why it is negative, indicated with negative. So equation 3. So let y is equal to h, uy is equal to u sin theta, since it is the vertical component. So substitute here u sin theta t minus half gt square. That's equation 4. Just you are replacing uy to u sin theta. That's all. And y is equal to h. Then equation 2 in 4. So take this equation 2 in 4. So y is equal to u sin theta x by u cos theta minus 1 by 2 g x by u cos theta square, whole square. So the 2 you know, this is t is equal to x by u cos theta. Correct. So in equation 2 in 4 you're supposed to see here u sin theta t you have to represent here, see, x by u cos theta minus half g, and again g t square x by u cos theta square. And if you simplify this, sin theta by cos theta, u gets cancelled. Sin theta by cos theta is nothing but tan theta x minus half g x square u square cos theta, u square cos theta. The parabola equation y is equal to ax square plus bx, either form or maybe it may be in the form of y is equal to ax minus bx square, ax minus bx square. So if you can better have this values in the way u cos theta square. That's the better way to represent x square by u cos theta square. Next, y is equal to ax square plus bx, and here b is equal to minus 1 by 2 g u cos theta square. Y is equal to ax minus bx square. Maybe either in this form or maybe in this form. The thing is that if you take the ax square plus bx form, see here this suits with ax square form and this is bx form. Either way, just change the sign and as well as the constants also. If you say this is a, tan theta is equal to a, and x is x, minus, and this complete functions 1 by 2 g divided by u cos square theta, that functions is become b, so ax minus bx square, or if you take this functions ax square, you can take it as, so either the way, you can take it as ax square plus bx. So if I wanted to make this as a and this as b, anyway the sign is changed, that's all. So a is equal to tan theta, b is equal to minus 1 by 2 g u cos theta square. The projectile path is parabola. Since it has the values similar with the parabolic equation, so projectile path is parabola. It's proved. Then expression for time of flight, uy sin theta, ux cos theta, uy is equal to 0 when it reaches the maximum height. Further it will not go, but you are written with ux is equal to u cos theta. V naught initial velocity, V final velocity, accelerations is equal to final velocity minus initial velocity by time. So this equation, you know this equation, just only I was clarifying this equation. Say this equation is A. If A is equal to acceleration due to gravity, A means here you can do one thing. You will make it as this equation 1. A you will get confused. Make this as equation 1. In equation 1, in equation 1, so keep this A is equal to G, downward direction. So 1 can be written for the vertical upward motion, V is equal to Vy, that is vertical component. Initial velocity V0 is equal to Uy, that is vertical component. A is equal to minus G. Here you will get as Vy is equal to Uy minus Gt. Similar equation that what we have written here. So when you written this, when t is equal to t by 2, when the time of a travel of the particles reaching from here to here, it is say t. Half of the stretch, when it is a maximum, I can take it as t is equal to t by 2. T is equal to t by 2. When it is reached at h, I can say at h, t is equal to t by 2. That's what I am telling you here. T is equal to t by 2 at h. So Vy is equal to 0. Further component Vy is 0. At h is equal to Vy is 0. Further height is not there. So Vy keeps us as 0. Then here you can substitute Vuy as a u sin theta minus g t by 2. Here I am substituting here t with t by 2. That's all. Then t is equal to time to maximum reach. Time is equal to 2u sin theta by g. 2u sin theta by g.